Hello, welcome. I'm Emmanuel. Now in this video we'll show you how you can retrieve soil information or soil moisture data from Google Earth Engine. And I am here in the Earth Engine data catalog. I will be used Python to retrieve some kinds of information from this data. Now this Google Earth Engine allows you to download soil moisture data at a specific time and a specific location. Now here I have several files in forms of CSV. As you can see here, I have bandis underscore 2020 CSV. Let me show you what kinds of data I have. Okay, my PC is a little bit slow. So as you can see, I have 1,800, around 800 or 1,900 data, and each of the data has its longitude and latitude and the time which were recorded. These are the information about desert locusts at early stages. So I want to predict the probability using the machine learning. I want to model some kinds of data. So here, given the longitude and space and the time, I will need some kinds of soil moisture data. Now I'm going to use again Google Earth Engine using a Python client library. Now I will show you the code how to retrieve some kinds of data. Here I have to import EE. Import EE you need to install by using pip install Earth Engine, and by following this an intro to the Earth Engine Python API, you can look this and you can easily install the Earth Engine package into your Python library. So once you install the Earth Engine, now you can import EE. If you have some kinds of authentication problem, you can read this page again. It's very straightforward and easy. You will install some kinds of required other tools, but if you are going to use Conda, it will be very simpler to use. So once you install and set up your Earth Engine, you just import EE as EE initialize, as you can see at line 4, and then we are going to use SMAP. SMAP means soil moisture active and passive at 10 kilometer resolution. Soil moisture, it is a product of NASA. Now it is starting soil moisture from 2017 up to now. Now every minute, in every minute it records and stores in every minute and every space will be recorded. Then that is a huge amount of data, so you can't download that amount of data into your local machine and search looking for what you are looking for. That will be very computationally intensive. So to avoid that, you have remote access using your client library. So this is why EE or Earth Engine is provided for us. It's very simple, and once you can connect by using this one. So I need this image collection from soil moisture SMAP again, and as you can see, the description of this SMAP is around here. You can read that one, and there are several bandis. So you can have SSM, SUSM, and SMAP for soil moisture profile, and these are the measurement units. It tells us measurement units and the minimum and maximum range. Tells you that this is an example you can retrieve, or you can see by using map. So you can execute this code. This is in JavaScript anyway by using online code editor or code in Google. You can see what you are looking for using map. But I want to model for machine learning, so I want the actual value of soil moisture data. So that here it is. So I will use my CSV. This is my CSV of the collection of the bands I have already downloaded. Then I need to retrieve the observation date only, because I have observation date column from my CSV format. So that is when the data is collected. Then, as you can see, this is a pandas df. data frame. Then you can use these kinds of index and row, def in it rows, and then once this is converted to a real date, or the object has been created, so I can say d whatever the variable and row such kinds of data. Now from that specific of date, I need to backward 2 weeks and forward 2 weeks, and then I will take the average. Okay, because soil moisture data is usually done by in monthly or weekly, because that is hard to retrieve. So you can use 1 week later and 1 week things to make accurate things, but you will take the average, the mean. So now this is initial date from this -1 week to previous week. That means total in 2 weeks. Then I retrieve some kinds of SSM, that band, and SUSM for subsurface soil moisture band. Then I retrieve from longitude and latitude from my data, and then I will point that by using a geometry.point from EE library. Then I just want to scale from I have some kinds of impacted area, so I just want to the scale. The scale here, it is SMAP is 10 kilometer, so I just retrieve. I have added some kinds of kilometers to this point, around that point. Then I will take, as you can see here, SSM.mean means I just want to retrieve some kinds of mean. You can take the median or any probability functions, and I need two, as you can see, two variables for surface soil moisture and subsurface soil moisture. And once you have written, then I write that value, this value, to another Excel format, and these two values, another Excel format. Just for simplicity, I just to see the value of the first one into console. And then finally, I have created this SMAP 10 km.cv file. Okay. Then I can use later on that one. So let me run it. Here I am. Let me go to here. This is sm_smap.py is my file. Open in terminal. I will open in terminal the entire directory. So I just execute this Python 3.smap. Let us see. So as you can see, it retrieves some kinds of data. These are soil moisture in millimeter. So you can convert into meter cubed to meter cubed. So these are the values of the soil moisture at that time and at that location. So I hope this video is useful for you, and don't forget to subscribe. See you in another video.